Okay, today for section 11.5, you're going to look at applications of trigonometry. So kind of story problems for the stuff that we've been learning this unit. So first off, when we're looking at problems that use angles of elevation versus angles of depression, the way you set your picture up is really important. So I'm going to draw a picture to help you understand the difference between the two. Angles of elevation and depression are angles that are based off of the horizontal line. So you can imagine if you're a person standing, here's a little person, when they are looking out, that horizontal line, you can think of it as being like the ground. So for an angle of elevation, that's where you're coming from the ground, but then the angle is going up like this. So we have this angle coming from the ground and then up towards something. So maybe they're looking at the sun or something up here, and they want to find the angle between the ground and the sun. So it's going to be the angle that is above the horizontal line, whereas the angle of depression is going to be the opposite of that. So think of maybe you're standing on a cliff. Here's a little person. Normally that person, if they're standing up here, their eyesight is going straight out, right? This way. That would be their normal line of sight. But then maybe they're looking at something down on the ground. Maybe there's a big rock or something they're looking at. So that angle of depression is going to be that angle coming down. So they're looking straight out at something, but then dropping their eyesight down. And then what happens is on both of these scenarios, we can make a triangle. If I bring this line straight down on this one, we have a right triangle this way. And on this one, if I have my line going straight out and then dropping it down, we have this triangle kind of up in the sky right here. And these are going to be the two scenarios for either an angle of elevation problem and an angle of depression problem. So the important thing on these is making sure you set the picture upright when you're doing a story problem, because if you accidentally do an angle of elevation when you should have done an angle of depression picture, you end up getting your answer backwards because these two sides switch with each other depending on which triangle you use. So you have to be kind of careful with that. So make sure you're setting up those pictures the right way. So let's look at this example. We're just going to practice labeling them. So it says label each angle as either an angle of elevation or an angle of depression. And we have this angle 5, angle 6, angle 7, and angle 8. So angle 5, I've got a little Jim here. His line of sight would be going straight out, and then it's looking up to something. So this one would be an angle of elevation. I'm just going to put an E by it. And then we have Kelly here. Same thing, her line of sight would be going straight out, but then she's looking up at something. So this one would be an angle of elevation. And then here we have angle 7. Got this little line here to tell us where it starts and stops. The horizontal line is here along the top, and it's dropping down to this angle. So this one would be an angle of depression. Put a D there. And same with number 8. We have the horizontal line, and the angle is dropping down to this line right here. So that would be another angle of depression. So angle of elevation is where that horizontal line is on the bottom and you're looking up to something. And an angle of depression is where that horizontal line is at the top and your angle is coming down. Okay. So before we just get looking at some more examples, angles of elevation and depression can sometimes have angles on the outside. So sometimes angles of elevation and depression will be found outside of the right triangle. You can use the fact that alternate interior angles are congruent to label the triangle or the angle inside of the triangle that is congruent. So that's going back to some of our previous units where we would have the parallel lines cut by the transversal, and we learned that alternate interior angles are congruent. They're the same size. So we can use kind of that same idea when we are labeling a picture. So if I look at this little picture right here, looks like we have a boat and its anchor is down here on the bottom of the ocean floor. And we know this angle is 50 degrees. So because we have these two parallel lines, you can think of this line as being the transversal. We also know that that angle is going to be 50 degrees. So we can apply some of those past concepts that we've practiced. Also, if we know this distance right here, I could find this distance would be the same, since we are making a rectangle right here if I make this a right angle. So if I know one side, I know the other, and vice versa. Let's say this was y long, then this would be y long. And we can find those angles here would match, and also these two angles would match since they're alternate interior. So now we should be good to start practicing some problems. So on this first one, it says find the value of x and round to the nearest tenth. We have this 27-degree angle up in the top corner right here. And they've told us this diagonal line, our hypotenuse, is 580 yards. And they want us to find this distance here. So you kind of have two options. You could, because we know this distance is the same as this distance, you could find this side and use this triangle. Or because we have alternate interior angles, we know that if this is 27 degrees, this one's also going to be 27 degrees. Let's say match. So if I set this up as my triangle, it's really just going to be one of our SOHCAHTOA problems where I know my hypotenuse. So if I'm coming from this angle right here, this 27, my opposite side would be x, and then this is our long side, so it's our hypotenuse h. And so if I think of SOHCAHTOA, remember that's going to help you remember, do I use sine, cosine, or tangent? We have O and H, so we want sine. So I'm going to set up sine of my angle equals the opposite side divided by the hypotenuse. So our angle that we have is 27. And then the opposite side we're trying to find, we'll just leave that as an x, and our hypotenuse is 580 yards. So if I'm trying to solve for x, to get rid of the divide by 580, we are going to times by 580 on each side. And those cancel, and we just get x back, and then this is what we're gonna throw into our calculator. So remember your sine, cosine, and tangent buttons are right here above our numbers. So we're gonna do 580 times sine of 27 degrees. We get 263.3 to the nearest tenth. And we were measuring, if this is in yards, this would also be in yards. And so that would be our answer. Okay, let's try another one. So we have this triangle right here. They've told us that this bottom is 2 kilometers long. They've said that this top angle is 18 degrees, but remember, if these are two parallel lines and this is cut by a transversal line, then this is also going to be 18 degrees. So we can label that one. And so now I have this angle inside of our triangle to use. So I label my sides. If this is 18, then side x would be our opposite side. This would be our hypotenuse, and then this would be our adjacent side. So this time we're looking for side O, which is x long, and then they told us that the adjacent side is 2 long. So I want to use tangent, since tangent uses O and A. So I'm going to use tangent for O and A. So if we set up our formula, tangent of the angle equals the opposite side divided by the adjacent side. That's the formula to use. So if I plug in my 18 degrees, x for my opposite side and 2 for my adjacent side, I get tangent of 18 equals opposite side x over the adjacent side 2. And just like the last problem, you want to times by 2 to get rid of that divide by 2. So those cancel, x comes alone, and then this is what we're going to throw into our calculator. So 2 times tangent of 18 degrees, and we get 0.6 if we just round to the 10th place. And then we were measuring in kilometers on that one. And that would be your answer. It's kind of just a small one. Okay, so those ones didn't really have stories to go with them. They were just diagrams that we pulled our info from. But we are going to look at some actual story problems. So here are kind of some steps to help you when solving these. Read the problem. Obviously, we don't want to skip over anything. And don't just start solving before reading it. You want to get all the problem information. So read the problem again to pick out any key info. So things like angles and distances we're going to be looking for. I recommend drawing a picture. We're going to be using a right triangle, and we're going to label it with the info, either the angles or the distances they gave us. And then once we have our triangle, we can set up our sides and figure out, am I using sine, cosine, or tangent? And then we can solve. So let's look at some examples. Okay, so you sight a rock climber on a cliff at a 32-degree angle of elevation. That's a key right there because that's going to help us know how to set our picture up. The horizontal ground distance to the cliff is 1,000 feet. Find the line of sight to the rock climber. So here's the ground. There's something with like a little rock climber up on here, right? So he's on the side of the cliff. You are down here on the bottom. And your angle of elevations, remember that's coming from the horizontal line upwards to the rock climber, is 32 degrees. They also told us that the ground distance to the cliff is 1,000 feet. So from you to the side of the cliff is 1,000 feet. They want to know, find the line of sight distance to the rock climber. So your line of sight, that's from your eyes to the rock climber. So that's going to be our diagonal here, our hypotenuse. So that's what we're looking for, x. So again, setting this up, we had to think about that angle. We had to think about the distance they gave us. And if it's an angle of elevation, how do I set my picture up? So remember that comes from the horizontal line being on the bottom and you're looking up towards something. So now that we have it set up, it's just going to turn into one of our regular trig problems where we have this little right triangle. And we first want to label our sides as opposite, adjacent, and hypotenuse. So that way I can know, do I use sine, cosine, or tangent? So we're going from this 32-degree angle. So across from it, this would be side O. The hypotenuse is always the long side. That's our side X. And then adjacent's touching the angle, which is down here on the bottom. So we are trying to find side X, which is our hypotenuse. And they gave us the adjacent side, which is 1,000. So which trig function uses A and H? So if I write my little SOHCAHTOA, that'll help me know. So cosine uses adjacent and hypotenuse. So the formula is cosine of your angle equals the adjacent side over the hypotenuse side. We're going to plug in our info. Our angle is 32, A is 1,000, and our hypotenuse is x. So cosine of 32 degrees equals our adjacent side 1,000 over our hypotenuse x. Hey, we haven't looked at one of these today where x is in the bottom. So if you remember back to our previous day, when x is in the bottom, the little trick that you do is you just switch these places. So x is going to come out here, and then you're going to have 1,000 divided by cosine of 32 degrees. So we're just switching their place. And then this is what you're going to throw into your calculator to get your answer. So if we do 1,000 divided by cosine of 32 degrees, we get 1,179. And if we round to, doesn't say what to round to, let's just round to one place. So that 7 will bump that up to a 2. So 1,179.2 feet. And that's how far away the rock climber is from you. Okay. Let's try another one. An airplane pilot sights a life raft at a 26 angle of depressions. Remember, that's telling you how to draw your triangle. The airplane's altitude is 3 kilometers. What is the airplane's surface distance from the raft? So we have an airplane. I'm not going to try and draw an airplane. Let's just say that's my airplane. And this airplane is going straight through the sky. So that's where it normally would be going. But then the airplane pilot sights a life raft 26 degrees at an angle of depression. So if this is my horizontal line, let's say our little life raft is out here. Here's the ocean. That angle of depression is coming down to that life raft. So our triangle is going to be up here in the sky. So that's the difference between a depression versus an elevation problem. So this angle is 26 degrees. And then they told us the airplane's altitude, that's how high it is from the bottom over the ocean. If this is 3, then remember how I mentioned this would just be making a rectangle? So if this is 3 going straight down, then this would also be 3 going straight down. So we can use that and just kind of move it over. So now they're saying, what is the airplane's surface distance from the raft? So for surface distance, it's kind of a weird term right here. They're saying, like, if this is like the surface of the water, what's the distance from the airplane to the raft? So we're kind of looking for this distance, which is also the same as the airplane to here. So they're wondering, how far does the airplane need to fly until they're right above that life raft to get the person that they're probably trying to save. So we're looking for this distance x right here. So we have our picture labeled. Once we have our picture labeled, we can go ahead and label our sides as opposite, adjacent, hypotenuse, so we know if we are using sine, cosine, or tangent. So if this is our 26-degree angle, across from it will be our opposite side. The hypotenuse is the long side, and then adjacent is going to be this one on the top. They gave us the 3 kilometers, so that's the opposite side, and we're looking for x, which is our adjacent side. So which trig function uses opposite and adjacent? And that would be tangent for TOA in SOHCAHTOA. So tangent of your angle equals opposite over adjacent. So we're going to plug in the 3 parts. We get tangent of 26 degrees equals the opposite side 3 over our adjacent side x. And again, when x is in the bottom, your little shortcut is you're just going to switch the place of these two. So x is going to equal 3 over tangent of 26 degrees. And that's what you'll just throw into your calculator. 3 divided by tangent of 26. And we get 6 point, we'll just do one place again, 6.2 if we round up. So 6.2, and you're measuring in kilometers. So that's how far the airplane needs to go before he's right above that life raft. Okay. Let's move on.